Like many people, I used to believe a product certification lasted for however long that product worked. I was surprised to learn just how quickly that certification can change. Good morning and welcome to the webinar, Electrical Product Certification Depends on You, not just the manufacturer. I'm Anthony, publisher of Electrical Business Magazine and today's moderator. I sincerely thank all of you for taking the time to attend today's webinar, and a special thanks to Hubbell Canada for helping us to deliver this important information to you. Now, before I hand over the mic, let me tell you a little bit about today's presenter. Marty Cole is a member of CE Code Part 1, Section 18. He chairs CSA Group's Integrated Committee on Hazardous Location Products, as well as Electro Federation Canada's Wiring Product subsection on hazardous location products. He is a member of the CSA TC 419 on the performance of lighting products, and associate member of CSA's Technical Committee on Industrial Products. In 2014, he was awarded CSA's Award of Merit for his work in hazardous location standards. I could go on, but we're also eager to get started. Take it away, Marty.
Hello, everyone. I'm Marty Cole, and we're going to talk about product certification today and what's needed to make sure that it stays in place. It's not just the manufacturer's issues, it's everybody's issue. So we're going to talk first about what most folks think product certification means. And then with certification, it all begins with standards. So we'll have a global look at what types of standards exist and how they're applied. Once we have the standards in place, then the certification process can begin, and we'll have a quick explanation of what's all involved in certification to standards, and then talk about what the role of the user is in maintaining compliance with the certification, what's necessary to make sure you're in compliance, and what happens if you accidentally void a certification. And it's more common than we think. What most people think certification means is that a product provides an acceptable level of safety. And that level of safety is defined by the authority having jurisdiction over electrical installations. In Canada, every province and territory is the authority having jurisdiction in their area. The intent is to reduce the risk of accidents that cause injuries or deaths. We expect things to be built to our national standards. In Canada's case, that's CSA and UL. We expect they're evaluated by an independent agency to applicable standards. And products will always have some indication that they're certified by either a mark on the product or some documentation. In Canada and the US, product certification is mandatory by our electrical codes, and it's the manufacturer's responsibility in most cases to provide it. But we use multiple terms for certification. We call it approved or approval. We say it's listed or complies with or conforms to standards. So we use multiple terms, and we'll talk about something more generic in a few moments. Certification is provided on all electrical products. The buyer has some proof. He's got a mark on the product that says it's certified, or he has a certificate or declaration of compliance. But not everything is actually certified this way. Many things are not certified this way. Not necessarily in all of our worlds, but in some of our worlds. The expectation is that the certification lasts forever. And technically that isn't wrong. So to understand more about certification, we need to look at what standards are. Standards define the design, construction, and performance of electrical products. There are consensus standards. These are developed by a group that includes a wide variety of stakeholders, certification bodies, manufacturers, regulators, users, consumers, and any other interested party. Again, we're defining the requirements necessary to provide a minimum level of safety as is defined by the regulation or by the standard committee itself. In this process, we talk about all those various stakeholders that are supposed to be participating. But in many standards, we end up with mostly certification bodies and manufacturers. We get a little bit of the regulators showing up. What's missing in many cases is a wide range of users. So anybody that wants to participate in a standard is able to do so. They just have to contact somebody like a CSA or a UL, who's ever writing the standards, to make it a better standard for everybody. And then there's industry or company specific standards, where other consensus standards are not necessarily available. These are developed by a limited number of stakeholders to meet the specific requirements for whatever the application is. These are very different standards, and while they can be certified to in some cases, in many cases, it's a very different kind of certification. Consensus standards are written by standards developing organizations. They address the technical and national requirements or international. In Canada, Standards Council of Canada has designated CSA and Underwriters Laboratories as standards development organizations. UL's new. They've only been SDO for about 5 or 6 years now, if I remember. In the USA, they have multiple standards writing organizations: UL, FM, ISA, NEMA, IEEE, NFPA. Globally, we get IEC standards and ISO standards. And then you have ones that come from a specific country, region, or economic area. For example, the European Union. Then we have industry-specific standards. Those, say, in lighting for the IESNA, in Illumination Engineering Society of North America, or in Europe, it's the CIE. These standards need to be reviewed and updated or reaffirmed on every periodic basis to address new technology, safety, or any other issues that may come up. They can't remain static. You're not supposed to have a standard that lasts for 50 years, even though we've done that in some cases in Canada. We're correcting those. And then we allow a mix of standards. Some are developed by a domestic organization and adopted by a country. So for example, IEC standards are adopted by multiple countries. They mean nothing, IEC standards, unless a country adopts them. So we adopt those with national deviations. And these are to just address the local regulations and installation code requirements. In cases where they don't exist, again, they might be developed by a company or an industry group. But once we have all of our standards in place, then the certification process can begin. The certification process, not to be outdone, also has standards. There's the ISO IEC Guide 17065 that says how certification bodies operate, the products they offer, the services they offer, the process they go through. And countries define the certification systems that they want. Most are based on the ISO IEC 17065 to define whatever standard is to be and process is to be used. And there can be multiple versions of this within a country. So for example, in Canada, we have the Canadian Electrical Code Part 1, which we use for most of our electrical installations. Then there's a Canadian Electrical Code Part 3, which is just for the utility industry in Canada. Then there's a mining electrical code. And there's a Canada Newfoundland Offshore Petroleum Board that has a separate code. So we end up with multiple versions of conformity assessment and codes. In the US, they have the National Electrical Code, the US Coast Guard, and the Mining Safety and Health Administration, which have their rules for certification of product. And certification in its simplest form just means conformity to assessment, conformity to standards. And conformity assessment means we meet those standards. Within conformity assessment, there's actually multiple types. There's a guide for that too, 17067 from ISO IEC. And it's how product certification and guidelines for product certification schemes are defined. And there's 3 basic systems. The first is first-party certification. In this case, items are self-declared as complying with the applicable standards. This is just done by the manufacturer or even the person who sells it or the representative of either of those. And this is really basically saying, I made a good product, you'll like it, I'm telling you it's good and nobody else can argue because nobody else knows. Second party evaluation is where the user or the purchaser of the product looks at an item to see if it complies with their requirements. So they're taking first party data, going through it and making sure it fits their requirements. These aren't used a lot in Canada, in North America, except by specific industries. We don't see a lot of this. It's used a lot in other parts of the world. Third party is what we use. It's investigated and documented by an independent testing and verification agency. This is what we think of in our electrical code as certification. It's using the ISO system, ISO IEC systems, and products are assessed to the applicable standards. Now, it doesn't matter what product we look at. Every one of them is done to probably more than one standard in our electrical world. There are basic requirements everything must meet, and then things on top of it. So we're not talking a single standard in most cases for a single product. So it's the assessment, evaluation, and testing of that product. And with that goes ongoing surveillance of production. Just because me as a manufacturer went out and certified a product doesn't mean that they're just going to let me build it off into my own little bubble without going back and having them come in a few times a year, 3 or 4 times a year, depending on the company, to make sure that I'm building it the same way it was certified to. So there's some investigation behind that. There aren't on first and second party. Now, when we talk about the global certification systems, this is a really great idea to have one standard that's globally accepted everywhere. Unfortunately, it doesn't exist. Global certification requires a lot of testing, a lot of expense to provide certifications that are acceptable for every country we want to be in that market for. You want an example of this? Look at the back of your computer, your phone, or your power supply. There are all kinds of certifications in here for all kinds of different countries. It isn't one certification suits all. We may get there someday, maybe when my great-grandchildren get old enough to enjoy it, but today, no. So why are there so many different certification systems, so many different standards in the world? Well, we have different interpretations of what safety means to us. What we're willing to accept and what others are willing to accept can be different. In some cases, this comes down to liability. Product liability, if something goes wrong, is much greater in some countries than it is in others. We see in the US, they can sue for just about anything, and Canada's not far behind them. There's less of that in some other countries because their laws are different. But we often use this just to control trade. If we put a tariff barrier in, somebody's going to complain about it. World Trade Organization will be telling us we can't do that. But we could use standards as a non-tariff trade barrier. In some cases, it's just somebody takes exactly whatever data you had and puts their certification mark on it for a country. The IEC Conformity Assessment Board has schemes, they call them, systems. There are 4 systems currently: the IECEE, which is for electrical equipment, the IECQ, which is for electronic components, IECRE, which is for renewable energy systems and products, and IECEX, which I'm heavily involved in. That's for equipment for explosive gas or explosive atmospheres. Each scheme has a method to issue a certificate of conformity that says it's been assessed to those standards. These aren't accepted globally. It's not like this is going to work in every country, but each system can also issue test reports, and those test reports can be used by other certification bodies for domestic certification. Primarily that's done with IECE and IECEX. We don't see a lot out of Q because they follow under different rules, and RE hasn't issued very many certificates at all. It's still a very small system that's trying to grow. If you look at the EX system, the IECEX system, they'll issue a certificate of compliance. The only places in the world that accept them as is Australia, New Zealand, Israel, Singapore. All other countries require a domestic certification. So we don't use the certificate of compliance. We use the test report that's behind that, the IECEX EXTR. And with that, we can cover off most of the test requirements for domestic certification. We do need to address any national deviations, but for the most part, those are pretty transferable between countries. But because they aren't linked to our certification and installation is not linked, that ends up being a lot of the deviations the country will put in to say, you have to use this electrical code, Canadian electrical code, the national electrical code, the Australian electrical code, whatever. IECE is very similar to IECX in how they operate, except fewer countries accept the certification, the certificate of compliance. They want just the test report. So they issue more test reports than they do certificate of compliance. It gets a little complicated. Now, the European Union is completely different. For hazardous locations, they have certain requirements, and for ordinary locations, they have requirements. Technically, these are all harmonized with the IEC. They have parallel voting. It comes in and it just works for them. But the system has more to do with trade than it has to do with safety. It's set up to facilitate trade between the member countries and their economic partners within the European Union. And products are required simply to meet the applicable essential health and safety requirements that are contained in European directives. And the manufacturer issues a declaration of conformity to those ESHRs. If these are met, they can apply the CE mark that says conformity to Europe, which is a first-party system, and apply that little CE, which means nothing in most of the world, just in Europe. When you get to the hazardous location side, they have the ATEX directives. ATEX is short for atmospheric explosives, the French. And for zone 0, zone 1, zone 20, and 21, if you understand what they are, a notified body must be involved. And they're sort of a third-party organization. In many cases, they are, because they do both IECEX and ATEX. But simply, that's a way for a country to see, we designate this guy to do our certifications for us, whether they're qualified or not. It's improved a bit more recently, but before, totally incompetent people could be issuing certificates under ATEX directives. When you get to zone 2 and zone 22, one's for gas, one's for dust, these are simply a declaration. There's nobody else involved. The manufacturer says, my stuff is good, it's safe, and you're bound to accept it because it meets the ATEX rules. I have a little difficulty with ATEX in that products don't necessarily need to pass every test in a standard 100%. They can get by with being close, as long as they're meeting the ESHRs. So if the standard says you have to be able to do this 100 times, or it's got to carry 100 kilos of weight, if you only meet 95, it might still meet the directives and still pass, whereas all the other systems would not let that product pass. It's still a work in progress. For ICX and ATEX, the normal, ordinary, and they look at electrical and non-electrical requirements. So they're looking a little bit more than we are in North America. But everything that has to do with the ordinary, the shock fire risks that go with the product, are self-declared by the manufacturer as complying with the applicable standards. ATEX does the same, self-declares the ordinary locations. In many offshore industries around the world, including the Newfoundland Offshore Petroleum Board, but not the US Coast Guard, they have no choice but to accept ATEX, simply because you can't build it any other way, because you don't have the requirement that you don't necessarily have to meet all of the requirements of the standard. So we see that being used in the offshore petroleum industry a lot. But those self-declared things are things that CSA and UL in Canada and US, we certify to. We certify to all the applicable hazardous and non-hazardous standards. We can use the test reports for some requirements, but we can't use any of the ATEX documents for certification. So our processes are different. They don't look at the ordinary location stuff for hazardous location. And in fact, most ordinary location products outside of North America aren't certified by third party. They're only first party certified. And even in hazardous locations, things like wire and cable, none of that is certified. There's no one that certifies wire and cable in other countries, unless there's some specific application for it. In our world, in Canada and US, we have standards and installation codes that are closely linked. We have installation requirements that a certification must meet. I can't have a rule in the Canadian Electrical Code unless I have a product standard to support it, and I can't have a product standard unless the Canadian Code has a way to address it. And certification is by a Standards Council of Canada accredited certification body. In the US, again, they have the same kind of rules using the National Electrical Code. For certification, it's an OSHA, Occupational Safety and Health Administration, nationally recognized testing laboratory, NRTL, that does that certification. And our codes are very prescriptive. They tell you exactly what to use and how to install it. And we have rules that all must be met for a proper certification or a proper installation. So it's a little bit different for us than in the other parts of the world where it's not a prescriptive code. It's a recommended practice. If you look around the world, they use other regulations, and it's basically get from point A to point B and do it safely. Whereas the Canadian Electric Code and the National Electric Code say you're going to go from that spot to this spot, and this is exactly how you're going to do it, how you're going to support the wires, what kind of wire you're going to use, and everything else. So ours are a much tougher code. And then we get different kinds of certification within our certified or listed equipment. It means that it's certified to the specific standards for equipment categories. Some of these things allow for some form of field modification, or we have a component program, a recognized component, where like a push button is no good unless it's in a box, but we certify the push button with no box because that's how it has to be done. But it's a component certification because it has to be assembled into something else. The US has some funny words, and depending on what agency you're talking about, they don't like using the same words. So they have identified where no standard or certification exists. That's where we get into first or second party requirements. They also have a classified program that says the box is okay if it's a box, for example, but you're going to do something to it, but we don't know what that is, but the box is okay, but we don't know what else is going in there. So identified, again, it requires a lot of different evaluations, owner's engineering judgment to decide if that's acceptable. We use some of this in Canada in the utility industry. And our certifications vary by application. A residential wiring device is not the same as an industrial wiring device or commercial. Some require a little more strength because they're going to be abused a lot more. We also look at indoor, if it's dry, clean, dirty, or subjected to hose down or submersion. Outdoor for, is it wet, AC, or submersible. Chemical exposures, extreme ambient temperatures, or hazardous location. And again, they're tested for everything. And just to be difficult, the Canadian requirements and US requirements are not the same. We've harmonized a lot of the standards, and that work is ongoing, but most of the key ones are done. Some may never be. Something as simple as the box that holds the switch in the wall. That's not a harmonized standard. They're different. The US products do not meet the Canadian standards, and the Canadian one might meet the US, but it's overkill by comparison. And our adoptions of the standards, of IEC standards, might have different national deviations because we link them to the installation code, and the National Electrical Code and Canadian Electrical Code aren't harmonized. So we have a different thing, a different set of requirements. So we need a separate certification for Canada and one for the US. Even though we sell to both of them, and most products that are common will have both, there'll be a different certificate. Some of the third-party agencies do offer certification for both countries, some don't. So if you look here, this is a Standard Council of Canada accredited certification body, and pretty much most of them do the same. And then these are the OSHA, Occupational Health and Safety Administration, testing laboratories. These are all the same. And then we get people that don't operate in both countries. ULC is, even though it's attached to Underwriters Laboratory, does our fire alarms. The rest of these people don't do fire alarms, and ULC doesn't do them for the US. SGS operates in the US and not in Canada at this point. So it's a different list. If you're trying to get something certified, it's easiest just to pick one of the guys that does both. Because there's lots of conformity assessment marks out there. These are just the ones from Ontario. And there's all kinds of agencies. Some of these are for ordinary location products only. Some are for hazardous location products. And some are just some of the other requirements that get certified to things for the gas code or telecom codes, etc. And our marks aren't simple. So these are Canadian certification marks. These are only good for Canada. They're not good for anywhere else in the world, or anywhere else in North America. And these ones are only good for the US. They can't be used in Canada. And then there's binational ones. We'll have a 4 o'clock US and 8 o'clock C that says it's good for both countries. The problem is they all look identical unless you understand what you're looking for. And lots of people make some mistakes on these. So certification means issuing a certificate of compliance. That's held by the manufacturer. They're the certificate holder. And technically, the COC is a historical document. And products are only certified when they leave the designated factory location. As a manufacturer, if I build a product in one of my factories in the US, if I suddenly want to build it here, I have to have that added to my certificate for certification documents so that I can do that. If I just build it here and send it out the door, it isn't certified. It has to go from the designated factory location. And we don't know what happens to the product if it still complies with the COC after it leaves. There's no way to know what happens after the shipment. Did it get there in one piece? Was it installed correctly? Is it being operated correctly? Or is it being maintained correctly? We don't know. Not everything that gets on a truck comes off the truck right. I guess the way to look at it is looking at certificates of conformity are much like birth certificates. Generally, everybody's issued one when they enter this world. And they don't expire. It just proves we showed up on the planet. Most certificate holders avoid getting their exit certificate, which is the next one we get as we expire. But what happens between those certificates has a billion variables. And it's not under the control of the manufacturer, the parents, or the certificate issue, the states. What happens? Why is one a pauper and one's a king? Certificate of conformity is no different. We build them, send them out, and we don't know what happens. If the product arrives to site undamaged, if it's correctly installed according to the manufacturer's instruction without any modifications, it's likely not affecting the COC. If it's installed incorrectly, depending on if it's safe or unsafe, you might affect the compliance of the SOC. If it's modified by the user, certainly that changes the COC, so it is often affected. If it's maintained by the user, certainly the compliance with the COC could be affected. Invalidating the COC can have safety or liability implications for the user. And the risk varies. What's an acceptable risk? If there's nothing that affects the safety of persons or property, there's little or no reduction in performance, that's an acceptable risk. We haven't done anything to make the product unsafe because we followed all the rules. Medium risk would be something that nothing of that affects the safety of persons or property, but it has tolerable or acceptable reductions in its functionality or performance. Things that are high risk are where there is a likelihood you've increased the risk to people or property, and there's an unacceptable reduction in performance and functionality. But it's up to the user to decide what that is. The manufacturer cannot tell them what that is. It's their liability, their risk, and they have to decide is it okay or not okay. Let's take something simple, a simple duplex outlet. If you reverse wire that, most of the equipment will continue to operate. There won't be any damage to electronic equipment. Even some GFCIs might work correctly. And this error isn't obvious, but it does happen all too often. There's an increased risk of shock, which could be fatal in some cases. So it is something we have to be aware of, that It's very easy to do when you switch those wires around. Now, we're not saying that doing this is anything compared to stupidity. I mean, some people do all kinds of things, and here you can see a good example of current flow. And in here, why someone would install the receptacle in the sink is beyond me. Certainly neither of these are in compliance with the COC, and they're probably very dangerous. Take another example. We buy a type 4 enclosure. We call them NEMA 4 just for convenience. And quite often they're bought without any openings. Cable entries, device entries are all added by the installers on site, or in many cases on site or at a panel shop. When done incorrectly, we might lose that environmental protection, and we might have water containment issues with ingress problems. So this is a type 4 enclosure. You can see water all along the door. How safe it is? There's water in the bottom of the box. In this case, they weren't too worried. They drilled some holes in this. But this is a type 4 box. This meant I can take a high pressure hose to that and not affect its performance. Well, if I start drilling holes in it, if it's leaking water on a regular day, it's not a type 4 enclosure anymore. If I needed that, it was a problem. But if there's no electrical safety issues, I might be able to live with it. But the manufacturer can't tell you that meets the requirements or not, because he doesn't know what you did to it. When we modify an explosion-proof enclosure, they're often bought without any openings. We're allowed in the field to put wire entries, but people also put mounting and operator openings in those boxes. Actually, only wire entries are allowed to be drilled in the field. We're not allowed to drill straight openings for operators, but people do that all the time. But we have no control over the quality of work. It could be anybody drilling that hole. If it's done incorrectly, okay, it might leak. That might be a problem. But we also might defeat the explosion protection that enclosure offered us, and that is a problem. Is it safe? We can't tell you as the manufacturer, nor can the certification body. They can't tell you if it's still in compliance or not, because they didn't do the work, unless they come and do a whole bunch of tests. Adding heat things in there changes the T code to a different or unacceptable level. People will put high current inducting devices in there. Some of the enclosures are not designed for this, and they could rupture under fault conditions. Unless the manufacturer did it, no one checked to see that that was okay. Even maintaining the box. There's a good example of a box. There's 2 bolts holding this door closed. There's an explosion-proof enclosure. If I use the wrong strength of bolts, because I lost all the other ones, if I stuck any bolt in there, that would be a problem. Did I damage the flame paths or scratches of stuff? Is it safe? We don't know. When it comes to lighting fixtures, people replace traditional lamps with self-contained LED or previously compact fluorescent, because some of the incandescent lamps runs obsolete and they want the longer life and energy savings. With hazardous location products, that's a bit different, because we have to make sure that there's no arcing and sparking things in there, and LED components don't always fail nicely. So this becomes an unsafe practice. Is the manufacturer going to be able to tell you that? Not really, because they don't know what you're putting in there. They don't know anything about the product that's in there. We see this all the time, where this is a Class 1 Division 2 fixture, and you can see the outline of the compact fluorescent. And this is in a major refinery. This is another one that they had where the whole lamp tube burned out. Is this safe? Not really, especially in the Division 2 or Zone 2 fixture, because these aren't designed to protect. In a Class 1 Division 1, it's probably not the end of the world, because the Division 1 is intended to contain an ignition. So if this thing fails and there's gas in here, a Division 1 fixture would handle that. But Division fixture is not designed for that. It'll blow to pieces. We also see a lot of people converting these things. This is a paper label on an explosion-proof riveted label to say nothing in this thing complies. This isn't a good practice either. And we can't say if it's safe or not, because we don't think it is, but that's our opinion. When you're doing maintenance, replacing the components, if the components are identical, there's probably no issue. But because the manufacturer didn't do the work, he can't say you took that part out and put the new one in correctly. Not up to him to say that, it's up to you. Is it certified? Probably okay. But if the components are only functionally the same, they may not be supported by the certificate. Certainly not in intrinsically safe systems. But if you took a any kind of a piece of equipment and it had brand A component in it, and you said, well, brand B is actually less money and it does the same thing, and put that in, it might not be supported by the certificate. So there might be a safety issue, there might not, we don't know. So when a product is shipped by the manufacturer, they issue the certificate of compliance. That's the only point we know that thing's correct. Keeping that certificate in compliance is the responsibility of the installer and the user, the owner of the product. The manufacturer, the certification body, has nothing to do with it once it leaves the door. So the users ask the wrong question. Is the product certification? That's a historical document. That date has long since passed. It was certified. It does have a certificate, but just like a birth certificate, what happened afterward is anybody's guess. Is it still certified after? Is it still certified after ship? If you changed it, only you can tell. So these are things we need to think about when we think about certification. It isn't as simple as we thought it was. Certification depends on all of us. The question to the user is, did you do anything that you might have altered the certificate? Was it installed correctly per the manufacturer's instructions? Did you modify it? And if you had it modified, did you modify it following those instructions? And is it being maintained along with those instructions? Manufacturers give you instructions for everything. And we know that in most cases, that's the last thing people look at. They go out with the other packaging without ever being opened. So if the answer to any of these questions is no, and you're not sure, then the product might not be in compliance. And it's up to you to assess the liability or the risk that you added to your facility. Thank you for your time.
Thank you very much, Marty, for all of your insights. We do have a little bit of time now for some questions. And again, you can just type it into the questions tab in your control panel. And barring any other questions that come in, Marty, I do have one question for you. And that is, you know, if someone is coming new onto a site to do some work and they see some suspicious or some product that they suspect might not be fully compliant, what are the steps? You know, let's say it's an electrical contractor, maintenance electrician coming on site. What are the steps they should be taking to start verifying that certificate of compliance, whether compliance is still being met? How do they get that installed product back into compliance?
There's two things. A product might be in compliance, but it also might not be a good certificate of compliance. We had some issues a few years back where if you were selecting a certification body, you might go to one over the other simply because they would approve just about anything. And I was involved in a project where they had a bunch of equipment on site, and it was rejected as not complying with the certification simply because even though it had a certification mark, it didn't meet the requirements of the standard, and the installer knew that. So he called that this was a problem, let the inspectors know that it was a problem, and they pulled the product back to the manufacturer, and something else was bought.
I have a question here about certified components equipment, component/equipment. So for example, one of our attendees is asking, a skid of certified components connected with each other, do they need a final certificate, or can the authority having jurisdiction accept this?
That's a bigger question. A skid assembly is typically first inspected by a certification body, but under our rules, they can't look at the interconnecting wiring. So the electrical inspector has to look at that. So there is a standard that's just coming into Canada now to deal with skid assemblies for hazardous location, where a certification body could do that, but most don't have electrical inspection as part of their scope of work. That will eventually come for them, but at this point, we still need the regular inspection to look at that. Depending on how big it is, if it's something small, then it could be treated as a piece of equipment, but as it gets bigger, like a larger skid, you're going to have an electrical inspector look at it as well in most cases. But that's something to be discussed with the local authority having jurisdiction.
How does product certification differ from Canada's Special Inspection SPE 1000?
So SPE 1000 is where something isn't certified. There is the SPE 1000, what it does is gives you the requirements the certification body needs to go through to assess it. It still goes through the certification body, and it's very much like a certification. They may be able to waive some tests, they may not, they may have to do some additional tests, but it's used quite often for the one-ofs or a batch of something. SPE 1000 is only good for non-hazardous equipment. You can't use that for hazardous location equipment. It's very close to a full certification, but usually a little less expensive and a little quicker to obtain.
Another question has come in, this one having to do with finding a method, or is there a method for finding compatibility of equipment, such as solar with a generator backup, or would it need to be in the certificate of compliance to show that it is compatible?
You might be entering different codes, and we get a disconnect between codes. And I'm not sure in that specific case if those panels, as they connect to other systems, pose an issue. I know that for certain things, we have a problem, which is why the standard for assemblies came along, or partially why it came along, where certain parts of a system in a petrochemical refinery, for example, required heating equipment, gas burning equipment, and electrical equipment. Well, those are two different codes, and they get close to each other, but they don't interlink. And that may be true in this case, and I'm not the expert in that arena, but it's probably along that. But you could say those within your certificate, they could identify the types of products, not necessarily by name, but probably by function that's acceptable.
Okay, thank you, Marty. I think we've got time for one more here. And also, just as a reminder to everyone, Marty's contact information is there on the final screen, his email and phone number. But we'll get to this question here. Is there a special inspection or field evaluation for hazardous location equipment?
You can't use SPE 1000. So there are a couple of different mechanisms within certification. They have an evaluation system for hazardous locations where it's basically a single unit. In IEC terms, which Canada also uses, there's something called unit verification where you can look at a specific item. Nowadays, you're getting pretty close to having to provide as much data as the original certificate had. It's just for batches or single items, and it can be done. You need to talk to the agencies. They all have that program within them, that ability to do one-offs, but it's a little more complicated than using SPE 1000.
Anyway, we'll wrap it up there. Again, Marty's contact information, email, and phone number are on your screen, so do feel free to reach out to him afterward for more in-depth questions and back and forthing. So thank you, Marty, and thanks to all of you for attending and sharing your questions with us. And of course, a special thank you to Hubbell Canada for helping us deliver this education through their sponsorship. Do visit them online at www.hubbell.ca. Meantime, also visit ebmag.com/webinars for recordings of all our past education sessions, including this one, which will be uploaded shortly. Thanks again, everyone, and I wish all of you an excellent day.